Welcome back, guys. So today we're going to look at group 7 elements. We're going to look at the properties of those group 7 elements and how they react. Before I go on to look at the new information here, just like I did before in my previous video with group 1, I'm going to flick back to the periodic table at the top and look at what we already know about group 7. So we know already that group 7 is under the number 7, so this whole column we have fluorine, chlorine, bromine, iodine and astenine that we're going to focus on today. And we know that group 7 elements have 7 electrons on the outer shell. And we already know this from our first video in this unit, so if you didn't know that already, just have a flick back and look at that video. To draw what group 7 element atoms would look like, I'm going to use fluorine as an example. Fluorine is in period 2, so it's going to have 2 shells. So again, we have our nucleus with the protons and neutrons. We have the first shell with 2 electrons, and then the second shell with 7 electrons. And chlorine, bromine, iodine and astenine will all have 7 electrons on the outer shell, but the difference will be that chlorine will have 3 shells, bromine will have 4 shells, iodine will have 5 shells, and astenine will have 6 shells. So for example, chlorine is going to have the first shell with 2 electrons, second shell with 8 electrons, and then the third shell with the 7 electrons. To go over another example, bromine, 2 electrons in the first shell, 8 electrons in the second shell, 8 electrons in the third shell, and 7 electrons in the fourth shell. So the outer shell is always going to have the 7 electrons. The second thing that we already know is, if we remember our stepping line, the group 7 elements are on the right of the stepping line. So what we know based on the metals and non-metals is that group 7 elements are non-metals. And that can tell us more about the properties of group 7, which we'll have a look at in a minute. So let's get started with the lesson. So first thing to remember is that group 7 elements are also known as halogens. So another way that we describe group 7 elements is as halogens. And you might have heard of some of the uses of these halogens before. So for example, chlorine is often used in cleaning products and to clean swimming pools, and in tap water as well, to kill bacteria. And it also makes water safe to drink and to be able to swim in. That's just some of the uses. Having a look at what the group 7 elements will look like, so the physical properties, they're non-metals, so they are going to have all those non-metal properties like low melting points, not being able to conduct electricity, being brittle, etc. But specifically, what's different for those halogens is that the colour of the halogens gets darker as you go down the group. So fluorine is quite a pale gas, and these are all at room temperature, by the way. Chlorine is a pale green gas at room temperature. Bromine is an orangey reddy liquid at room temperature. Oops, what's happened to my board? Let me try that again. So it's an orange /red liquid at room temperature, and iodine and astatine are solid at room temperature, and they're quite dark. And that is what they look like. Looking at the trends in the melting and boiling points, so other physical properties, the melting point will increase as you go down the group, and the boiling point will also increase as you go down the group. And you can see the figures for those on here. And this is quite different to group 1, where the melting point would decrease as you go down, and the boiling point would also decrease as you go down. It's the opposite here because it increases. And then moving on to look at the chemical properties. Unlike group 1, where the reactions get more vigorous as you go down group 1, in group 7, the elements become less reactive as you go down. So the reactivity of group 7 elements decreases as you go down the group. And this is really, really important to remember. One of the most important things that you need to remember for this lesson. So the reactivity decreases as you go down the group. And this is the opposite to group 1. And I'll tell you why this is more important in a minute when we get to displacement reactions. So just to go over that again, fluorine is going to be the most reactive, and astatine is going to be the least reactive. So to have a look at some of the chemical properties of halogens, what we do is we react it with iron. And when halides, so that's what we refer to as halogens, react to iron, we get iron halides. So when they react, we say halide, or if we look at it specifically, we say the ide is what's important. We turn the chlorine into chloride, the bromine into bromide, the iodine into iodide. So iron plus chlorine goes to iron chloride, and they react quite vigorously, and it would be quite similar in all of the elements. Next, this is the tricky bit of the lesson, which is displacement reactions. And this is something that you all told me that you found the most difficult. So we're going to focus on this right now. So the displacement reactions, in simple terms, are when one element in group 7, so one halogen, replaces another halogen and moves in its position. So displacement is the action of moving something from its place or position. And we're going to have a look at that now. Let's go back to our periodic table because it's going to be easier to explain it when we see it on there. I'm just going to get rid of these annotations. So we have our group 7 elements. If we react these group 7 elements with, for example, sodium, so if we have sodium plus chlorine, it's going to form sodium chloride. Remember the ide when we react it. That's what's going to happen. And hopefully you should be happy with this so far. So this isn't a displacement reaction. The displacement reaction happens when we add another halogen to sodium chloride, or it could be anything chloride. So the displacement reaction, for example, if we have sodium chloride and we add fluorine to it, what's going to happen? And we had a look at this in lesson very briefly, and we're going to explain it one more time. So if you remember from the chemical properties, I told you that reactivity will decrease down the group. So reactivity decreases, I don't have much space, decreases as we go down the group. So fluorine is the most reactive, and chlorine would be next, bromine would be next, iodine would be next, and acetylene is the least reactive. So I want you to think of the sodium or any other element in the place of sodium as quite unloyal. It's like a really unloyal friend. What it wants to do is it wants to be with the most reactive element. It wants to be with the cooler, or you could say, element. So, and it's going to leave the less cool or less reactive element to join with the most reactive one. So what it's going to do, it's going to bond with fluorine instead to form sodium fluoride. And then pour chloride or chlorine gets left by its, let me write that again. So, and pour chlorine gets left on its own, and it's quite sad because of that. And that is basically what a displacement reaction is. It's when one element replaces another element in a reaction. I'm going to go through another example. I'm going to get rid of this. So in this example, I will have potassium. So for example, if I have potassium bromide and I mix chlorine in it, the first thing I want you to think about is which one is the most reactive. So is chlorine most reactive, or is bromine most reactive? And remember, reactivity decreases as we go down, so we know chlorine is going to be the most reactive. So again, potassium, remember, it's not loyal, so it's going to want to be with the most reactive element. So it's going to join the chlorine. So it's going to form potassium chloride, and then pour bromine will be left by itself because it's not as reactive and not as cool. So that is another type of, that is another example. Sometimes in an exam, what they might do is say to you, will this reaction take place? They might ask you this question, and then they'll give you sodium chloride plus fluorine going to sodium fluoride plus chlorine. And you will have a look at this equation and you'll say fluorine is more reactive than chlorine. So sodium is going to join with fluorine instead because it's more reactive and leave chlorine on it by itself. So you will have a look at this reaction and think, yes, that will happen, and you'll put a tick next to it or say this reaction will happen. However, they could trick you. They could say, they could give an example of sodium chloride mixing with bromine going to sodium bromide plus chlorine. Will this reaction happen? So what I want you to do, I want you to take these steps, look at which one's the most reactive, because remember, sodium wants to be with the one that's most reactive or most popular. So which one's the most reactive? Is it chlorine or bromine? Chlorine is at the top, so chlorine is the most reactive, and sodium is already with chlorine, so it has no reason to go to bromine instead. So it's going to stay with chlorine. It's not going to join with bromide. So this reaction will not happen. And that's one of the trick questions you'll get. Another type of question you might get, and this is the last thing I'm going to go with you today, it might give you a reaction and it will say the colour of the solution, for example, is orange. If the colour is orange, I want you to remember when we looked at the physical properties of the elements, you would automatically think, oh, bromine was the orange liquid, so it's the bromine that's going to cause the solution to become orange. Again, if they say a green, anything green or a gas, you'll think it's chlorine because the chlorine is the green gas. If it's darker colours, you'll know it'd be iodine or acetylene. And that is another way that they can trick you out. I think there was an example of this type of question in lesson 4. If we have a look really quickly. So something like this. So below in the table are observations recorded from an experiment for displacement reactions of halogens from their compounds. So we have chlorine water. If we react it with potassium chloride, it's already having chlorine inside. It's going to have no reaction because it's already got chloride in it. So no displacement reaction is going to occur. Okay, so if we have potassium bromide solution and we react it with chlorine, potassium is going to join with chlorine instead and leave the bromine by itself because it's been displaced, and the bromine will be a yellow brownish color because it's been displaced. Again, if we see potassium iodide reacting with chlorine water, the chlorine is going to displace the iodine, and the iodine will be a brownish color that will be seen. So the color is whatever element has been displaced, so whatever is left at the end. So for example, if we have chlorine reacting with potassium iodide, we will get potassium chloride plus iodine, and it's that iodine which will be the brown color. So the color is going to be the color of whatever is left by itself at the end. So always remember, if it's bromine, it will be yellow or browny or orangey. If it's iodine, it will be a darker brown. And this is what the colors represent in the reaction. And if there is a color change, you know that the displacement will probably have happened. If there's no color change or no reaction change, then you will observe no difference. I do understand that this is a bit of a trickier level, it's a bit of a higher level question, but hopefully the more we look at these questions, the easier it will get. And that is it for Group 7. That's everything we need to know. Hopefully this video helped. Again, if there's any more questions or anything specific that you need me to look at, just drop me an email or let me know in lesson and I'll be happy to help.